Hi, my name is AINATASYA Binti MOHAMAD HAMIZI. Firstly, introduction. Banana is an important fruit crop as its nutritional status is higher than other common tropical fruits. The banana is a fruit crop that is economically successful and has a sizable domestic market as well as significant export possibilities. Economic importance of banana. Volume. Banana are one of the most widely cultivated fruit crop globally. According to the Food and Agriculture Organization, the global production of banana in 2020 was approximately 160 million metric ton. Value. Banana are a major commodity in international trade. In terms of export value, banana consistently rank among the top traded agriculture products. The largest exporter of banana are Ecuador and the Philippines. Uses of banana. Firstly, fresh consumption. Banana are popular and affordable fruit that is enjoyed by people of age worldwide. Banana provide vitamin C, B6, dietary fiber and mineral. Second, food industry. Banana are widely used as ingredient in various food products such as a dessert, baby food, smoothie and more. After that, employment and livelihoods. Then, economic development and lastly, value-added products.
Assalamualaikum and hi, my name is Siti Binti Shafiee, matrix number F20A0601. I want to present about trait to be improved of banana. First, pest disease, which is fusarium. This pest can affect the stem and the root of banana, and this disease become worse because of the climate. And this disease had changed the production of banana industry. Then, for banana improvement, transgenic and gene editing require gene identification proceeding work. Gene editing, those approach need information about gene executed for the desired trait. Mapping is an approach to identify the genes, and benefit genes have been instituted into banana with a focus on the gene conferring resistance of fusarium.
Hi, my name is Jason and my metric number is F20B0724. So I'm going to talk about the biology of banana in terms of reproductive system and propagation method. So for the reproductive system of the banana plant is a perennial herb that belongs to the family of Mosa. It has a complex reproductive system that involves various structures and processes. The reproductive structure of a banana plant include the inflorescences, flower, and the fruit. The inflorescence of the banana is a large cone-shaped structure commonly known as the banana branch. For the flower, the banana flowers are unique and quite different from typical flowers. They are also considered to be terminal since they have 3 petals and 3 sepals. And for the fruit, after pollination and fertilization, the banana flower develops into fruit. The fruit is a berry with a soft, fleshy pulp and numerous seeds embedded in the plum. However, most cultivated banana varieties are seedless or have reduced seed due to the parthenocarpy, and a process in which the fruit develops without fertilization. The next one is the propagation method of banana. Banana can be propagated through both sexual and asexual means. The most common method used in commercial banana production is sexual propagation, which ensures the desired traits of the parent plant are maintained in the offspring. Sexual propagation, also known as vegetative propagation, there are 3. The first one is suckers. The most common method of sexual propagation is by using suckers or offsets. Suckers are new shoots that emerge from the base of the plant, parent plant. The second one is rhizome division. In some cases, the underground stem called the rhizome can be divided to create new plants. The rhizome contains buds that can develop into new shoots when separated and planted. And the last one is the tissue culture. Tissue culture or micropropagation is a laboratory-based method used for mass production of disease-free banana plants. It involves taking small tissue samples from the parent plants and culturing them into a controlled environment to produce numerous plantlets. The next one is the gene identification. There are 3. The first one is mapping. creating population by crossing and selfing the accumulate desired lies, phenotyping and genotyping, constructing the linkage map, and find mapping. Find out the markers associated to the desired traits. The second one is verification and validation. Should PL verification by overexpressing, suppressing, and knockout. Gene isolation in terms of isolation gene candidates, and gene validation by verification gene to the traits. And the last one is desired genes, transfers to targeted resection, and markers assisted selection. It's all from me. Thank you.
Mapping provide a straightforward information of markers associated to traits on the chromosome. Markers associated to traits on the chromosome will useful to identify the genes and develop marker assisted selection. This is gene identification. First, mapping, creation, population, crossing or self to accumulate desirable allele. Second, phenotype or genotyping, construction the linkage map. And third, find mapping, point out of the markers associated to desired trait. Second, verification or validation. In this part, have QTL verification, gene isolation, gene validation. And third, the isolation desirable genes have transfer to target association, marker assisted selection. This is disease evaluation, the race 1 and TR4, where the first is the symptomless of the disease and 6 is the worst symptomless. This is a leaf, banana, and rhizome. This show the race 1 and TR4 resistance, the rhizome score and leaf scores. The race 1 is a single dominant and TR4 resistance is additive in a coupling perhaps with the race 1 resistance. This is an SNP is a single nucleated polymorphism to marker assisted selection MAS. This is the 4 sequences on deep chromosome 10 that likely associated with the resistance to develop this marker from molecule exist selection. The sequences is they so can design the primer to apply it to the resistant plant, and that see the susceptible plant and to see the response of the marker to the resistant and susceptible one. This is the resistant genes candidate for MAS and genetic improvement. This is between the resistant and susceptible for a plant.
Okay, hello, my name is Mohamad Amirul Asyraf and my matric number is F20A0452. Okay, I am from group 13. Okay, for justification of the approach, genetic linkages map. So we developed with the Joint Map 5 software. The marker were assigned to homologous chromosome, taking linkages or repulsive into consideration. To identify the marker connected to the resistant, we utilized the MapQTL6. A permutation test was used to compute the logarithm of odd LOD criteria for significance of quantitative trait locus QTL using 95% confidence level and 1000 permutation. A marker exceeding the barrier were meant to be indicator of the resistance. Okay, next is genotyping. So we collect the leaf sample from segregation population. These were localized in order to separate the DNA and the DNA concentration per measure. The quantity were calculated using a monochromator, and the quality were evaluated using electrophoresis on 1% agarose gel.